What's poppin', dogs? Mr. Allen here, writing some equations of lines given different scenarios here. We got parallel, perpendicular, and a perpendicular bisector problem. This one's going to get a little messy, so stick around. First one, though, we got write the equation of the line parallel to 2x plus y equals 10, containing the point 45 in slope-intercept form. Well, what are the two things that we need to write an equation in slope-intercept form? It's in the name, the slope and the y-intercept. So what I like to often do is I write down my fancy m for slope and my b for my y-intercept off to the side, and then I'm going to do a little bit of math and we'll put the full final answer together in slope-intercept form, which is y equals m, fancy m, x plus b. Okay, that is our slope-intercept form. That's what our final answer is going to look like, but m and b will be numbers, x and y will be variables, okay? So we got to get our slope here, because if I get my slope, I can use that slope and this point right here to get my y-intercept. So that's the order of operations, if you will, here. Let's get our slope. How do I get that? Well, if we look back in the problem, we want it to be parallel to 2x plus y equals 10. So I'm going to use that equation to get the slope of that line, and then it's going to be the same since it's going to be parallel. But first, I need to rearrange this into slope-intercept form. Let's subtract 2x on both sides, and I'll put that in a different color here. I'm going to have y equals negative 2x plus 10. Okay, so what's my slope? My slope is negative 2. Beautiful, halfway there. Now let's get the y-intercept. How do I do that? Well, I could use the information here. This is an x and that's a y. It's a point on that line. If I substitute in 4 and 5 for my x and y respectively, and the negative 2 for my slope, I can get my y-intercept of the line that's parallel to this guy and contains this point. Awesome, fantastic. Let's do it. So I got 5 going in for y, so 5 here. Negative 2 is my slope. My x value is 4, and I don't know my b, but we are about to figure it out. So I got 5 equals negative 8 plus b. I'm going to add 8 to both sides. What is that? 13 then equals b. Boom, 13. Am I done? No. Common misconception. Everyone's like, oh, cool, I'm done. Wonderful, dope. No, you didn't answer the problem, bro. It's going to be y equals negative 2 x plus 13. That is the equation of the line. That is going to be parallel to this one given in the problem, and it will contain that 0.45. In fact, if I were to throw in 4 for x, I should get 5 for y. Shouldn't I? It's a point that's on the line. If I plug in 4, I get negative 2 times 4 is negative 8, plus 13 is 5. I got 5 on it. All right, next one over here. I doubt anybody got that 90s hip-hop reference. Oh well. Write the equation of the line perpendicular to 3x minus 9y equals 7, containing that point, negative 2, 3 in slope-intercept form. So the process is going to be very similar. I am going to jot down where I want my m and my b. We'll throw that over here. M, fancy m, and b. All right. So rearrange the equation here so I can figure out my slope. But this time, it's not going to be the same slope. So let's write it down here because we got a few more steps in this one, it looks like. Not as quick and easy where we just subtract the 2x and it's good to go. I'm going to subtract 3x, so I'll get 9y equals negative 3x plus 7, and divide by negative 9. Ooh, negative 9 on that 7, that's terrible. But fortunately, we actually don't have to worry about that negative 7 ninths. It plays zero role in this problem. The only thing I'm worried about is right here, which is 1/3 simplified x minus the 7 ninths. So a lot of times people are like, oh God, terrible fraction. That's awful. It doesn't matter. I don't care about the y-intercept of this line. I care about the slope of this line. And the slope is 1/3, but what is my perpendicular slope? And I might even jot that down, throw a little perpendicular right here. It's going to be the opposite and reciprocal. So flip it, that's 3, change the sign, negative 3. That is my perpendicular slope that I'm going to be using for this line that is perpendicular to the given and passes through that point. Now, next part, we're just going to figure out our b value, right? Just like we did before. So let's keep it going here. I'm going to switch colors, so it's because it's a different part. But we're going to go with y. This is y right here, and this is x. So we got 3 equals my slope, negative 3, my x value, negative 2, plus b, and I'm going to solve for b, just like we did before. Really, all these problems are kind of the same, just like a slight twist at the start, and then we transform it back into a problem that we know how to do. For this one, I know how to write an equation of a line when I have a slope and a point. So let's figure out my slope, and then the process is the same. Here, if we just did this problem, same idea, get my slope, but this time it's the opposite reciprocal. Now we're going to find our y-intercept. So if you can try to make those connections that there's a lot of similarities in these problems, it'll make your life a lot easier and not feel like everything's totally different. Because I know that can be challenging and a bit frustrating in math when you're like overwhelmed. You're like, oh my God, so much going on. Everything's different. There are a lot of similarities, but there are a lot of challenges too. So I'm almost there. I got to subtract 6 on both sides. I get -3 for my b value. So negative, oh my, I did not plan that they were both going to be -3. But hey, that's how the cookie crumbles here, baby. So we got y equals my slope of -3, x, my y-intercept -3. That is it. That one is going to be perpendicular to this guy right here. And it's going to contain that point, -2, 3. Bingo, bango. All right. Last one, and I did say this one could get a bit messy here because we were trying to write the equation of the perpendicular bisector of AB in slope-intercept form if A is this and B is that. Perpendicular bisector. What are we even looking at here? Well, let's do this. Let's do a quick rough sketch here as to what we're really looking at. So I'm just going to do an XY coordinate plane. I'm not going to scale it out or anything like that, but I am going to label it here, -6, 3. That's going to be our A value right here. And then B is 2, 11 up here somewhere. Okay, this is B. So I want to get the perpendicular bisector of that line, right? So we're looking at something that needs to be perpendicular, so a right angle, and it needs to go through the middle there, right? So this is essentially what I'm trying to do. Perpendicular, and it bisects it, okay? So it's going to be splitting it evenly on each side there. So that's what I'm looking for. This is my goal here, right? So it should have, it looks like a negative slope based off this picture. AB should probably have a positive slope based off this picture. And then what point am I going through here? Midpoint, ring a bell? Yes. We already need to bust out the midpoint formula, so we'll do that somewhere in this process. But for now, what we can do is we can either find the slope or the midpoint. Doesn't really matter. I'll go with the slope first. Let's find the slope of AB, because then I can just do the opposite reciprocal like I did over here to find the slope of my green line right there, okay? So let's see here. I'll keep it orange so that's dealing with AB here, and that makes sense. So slope, we got change in y over change in x, so 11. So slope here, 11 minus 3 over change in x, 2 minus -6. 2 minus -6. So we've got 11 minus 3, that is what, 8? 8 over, oh, maybe this won't work out so bad. 8 over 8. Okay, so we have 1. Lovely. So that's the slope of my line right here, AB. What's the slope of the green guy here, the perpendicular slope? Well, it's going to be the opposite and the reciprocal, so I will jot this down in green here. Perpendicular slope. Opposite would be negative, and the reciprocal of 1 is still 1, right? It's one of those weird cases. You don't see it too often, so we often freak out. We're like, wait, what do I do here? It's just -1. So this is a +1 slope. That's a -1 slope. And honestly, it looks relatively to scale as well. Okay, so we got our slope. Now we got to get our point. Our line is not passing through A or B. I got to find that point, which we said was going to be the midpoint, okay? I'm going to put that in blue here, and we'll do the work in blue. So that is going to be my point that I'm looking for. What is the midpoint formula? It's honestly, it's x2 plus x1 over 2, comma y2 plus y1 over 2. I feel like sometimes it's a bit much to remember. I'll write it down for you guys. It is x2 plus x1 over 2, comma y2 plus y1 over 2. So if you're a formula person, you like to remember that stuff, this is the midpoint formula. But what I like to do is I'd like to just remember it in more words. The average of my x coordinates, the average of my y coordinates, right? I'm adding my x's, dividing by 2. It's the average of the x's. Average of my y's, right? That finds the middle. So either way you slice it, whatever you got to do to remember it, that's you. It's all on you. All right. So my average of my x's, I got 2 plus -6. So 2 plus -6 over 2, comma, and then we have our y's, 3 plus 11. So 3 plus 11 over 2. And you might be like, wait, bro, you flip-flopped there. I did. But because it's addition, it doesn't really matter whether I do 2 comma plus -6, that's -4 over 2. And then if I did 3 plus 11 or 11 plus 3, doesn't matter. But if you are like, bro, I can't handle that, I will rewrite it for you. Don't worry. I'll rewrite it. Midpoint formula, the order does not matter. Whereas in slope, you got to be consistent, okay? So I think it's in best mathematical practices there that I am consistent, okay? So let's see. We've got the coordinates here. I'm going to bring her up. We got a lot going on here. We said -4 over 2 and 14 over 2. So let's finish that out. -2, comma 7. That is the point that is on that line. Okay, that's this guy right here. -2, comma 7. All right, dope. So remember, midpoint is an ordered pair. So we have the comma separated there. I apologize again for flippy-flopping the y's there, but again, it's addition, doesn't matter, but it can be hard to remember where it matters, where it doesn't. So consistency is probably best. All right, we are still not done. We got to put this in the slope-intercept form. I got to get my y-intercept. It looks like it's some kind of a positive number somewhere around here, maybe like 3, 2, 1, I don't know. Let's figure it out, shall we? Let's do it. Let's do it. Well, this is my x, this is my y on the line that I want. So what we can do here is I can plug that into my slope-intercept form that we wrote down here. I'm going to have 7 equals, and then we said my slope is -1. You gotta look back at all that work. My x value is -2 plus b. So we got 7 equals 2 plus b. Subtract 2, and I get 5 equals b. Are we done? Almost. Let's write our final answer now, guys. Y equals -1x, or just -x plus 5. Woo! That's a hefty problem there. The perpendicular bisector. Really the toughest one, I would say, in writing your equations of lines, if you're going to be tackling something like this in an Algebra 1 class. That is a lot. I like to throw this one at my Algebra 2 honors kids as a good way to review and think about all the different parts that you need in writing equations of lines, because it goes over midpoint, finding slope, perpendicular slopes, and also just finishing out writing that equation of line. So tough problem there. If you were challenged with that one, it's okay. I got other ones like it, so you guys can try another one. But this is a great recap of the more challenging aspects of writing equations of lines that are parallel, perpendicular, and the perpendicular bisector. If you have any questions, comments, concerns, whatever it is, pop it in the comments. If you just want to say, "What up, dog?" I will say, "What up, back?" And if you have any requests for other videos, let me know. Otherwise, thank you guys for watching, and have a wonderful day.